Hey guys, I'm Olivia. I'm running through this software called 3D Slicer in which I explain how we segment geometry based on images that we have. So usually in the medical world, you will have DICOM file in where they have CT scan and MRI and where you get all the DICOM file. But in this case, we will be having just images that we use with one of the system that we have. So first we load the data. So we load the images that we have. We choose file. We pick images that you will be given. So just click one of the image and click open. Because we are rendering the whole volume, we will need to untick the single file so that we get the full volume of the image that we have. So now we have image that is loaded, and what we do, if you right click your mouse button and just toggle around the image, you will be able to change the intensity of it. And this button here, if you pin it, you will be able to select different things. In this case, I'm selecting the axis so that I can know what's going on in my volume. And if you want to change the view, you can probably use one of these options. So I'm using the conventional, in which I have 3 different view and one view here with the volume. So now I'm just going to change the intensity so that I can segment my geometry better. So next, we will have to set up our volume to be ready for segmentation. So what we do is we click volume, and here we have different volume information. So we'll set it to 0.2, all 0.2. That's just because that's the image spacing that we use in the system that we have. So if you click this square button here, for all 3 views, you will be able to identify 3 different views that we have. So that's the view that we have, and if you move this button around, you will be able to see the entire stack of image that we have. So that's the volume. So the next one that we will be changing is volume rendering. So we are still in the volume, setting up the volume for segmentation. So here we'll be able to see the different inputs that you want. So we will just keep it by default. And next we will have crop volume. So in crop volume, you can display the ROI. So the ROI essentially is the region of interest. So you can fit the volume, and you can see that this is the volume that we have. So essentially this is the images that we have. And if you just apply, so everything will be set by default, and you just apply. So then you will have the volume that you'll be working with. So next we will be moving on to segmentation. So segmentation essentially is, with all this image that we have, we will be segmenting to a 3D geometry. So imagine all this image that we have. We will be moving towards a 3D geometry in this region of interest, right? So let's go to segment editor, and we will add one segment first. So I'll just rename this as vein. So essentially we will track the vein that we have, that it's in this image. So there's different effects that you can have. So there's paint, and there's draw, and there's level tracing, and there's threshold. So these are the 4 different things that people usually use to segment a geometry. So if your grayscale is obvious, you can use threshold. But if you look at this image, the grayscale is not very obvious, so you can't really segment it based on different threshold. So I'll be using the manual method where we use paint or level tracing. So I'll just work on this image, so I'll use the red slice only. So if you look at this image, for level tracing, it will trace the outline of the lumen. And for paint, essentially what you do is you will draw the lumen. You can increase the size here, depends on how big the lumen is, or you want to zoom in the image by just zooming in with the scroll button. So let's try one of the slices. I'll go back to conventional and I'll use paint, and I will increase the size so that it's easier for me to visualize. So what we do first is that we follow through this image. So we follow through this lumen here, and if you look at there, we will follow through all this lumen to capture the vein, right? So let's do that first. So I'll start with the end of the picture, which is somewhere here, and I will increase the size so that I can draw it, and let's just follow through. And this is the start of the image. So what you do is just following through the image to capture the lumen. So now if you look at this image, so that's quite mushy here, you can't really see what's going on. So but this tool view will help you see what's going on, right? So this is basically the connection for the other two arteries. So you will see the full image after we finish the segmentation, but essentially this is the connection bit where you will need to pay more attention in. So essentially this will be the one that you will need to capture. So when you capture the image, you don't have to, well, if you can draw it perfectly, that would be great, but if you can't, you will do smoothing at the end, where you will be able to fix your image essentially. So if you look at this picture, you can still get the tracing. Can use tracing. Tracing will be just tracing the lumen outline, but it will be tricky when the threshold is not clear, so you'll get like other parts here that you don't really want. So we will just stick with paint. Paint will be, well, it's quite taxing, but it will do what we need to for this geometry for your assignment. So this is the part where you capture the anastomosis. Anastomosis essentially is the connection of the vein and the artery. So if you can see, that's a pretty long thing here that you will need to capture everything. So yep, just capture everything. Capture everything. So if you make a mistake like that, then you can just undo, or you want to erase, that's fine. So now we have done all the paint for most of the image and I follow through. But if you look at the 3D, Show 3D, you will have all the different circles that we see here. So these different circles have to be filled with space. So we fill between, now we click fill between slices and we initialize. Essentially what it does is it interpolates the different circle based on the one that you have indicated. So, and if you show 3D, you have the full geometry, and if you apply, it gives you a 3D geometry that we have here. So that's the vein, and for this image that we have here, we have another segmentation that we need to do. I'll name it the artery. So for the artery, essentially it's this part here. It's actually harder to segment because you can't really see the artery. So this is the artery. It gets harder when it comes to places like that if you move through. So that takes a bit more time compared to vein. So let's just zoom it in so that we can see properly. Alright, so I'll start with paint. So it's easier for me if I hide the button on this bit here so that I can focus on the artery. So same thing, follow through the artery. it's trickier at the anastomosis. So you have to have an overlap. If I unhide the button, you can see the overlap between the artery and the vein. That's just so that when you fill it together, fill the spaces and do smoothing, it will be a full geometry that we see. So same thing, I will follow through and follow through the artery. So now we have two different parts if you show it. So there's two different parts that we work on separately to create the segmentation. But we need to combine the two of them into just one segmentation so that we have just one 3D STL file. So what we do is we can click the logical operation and click add and apply. So now you can see that that's just one color, and that's just telling us that, you know, we have one geometry here. We can hide this button so that we are just working on one geometry, one segmentation. So now we work on one geometry, but look at that, it's quite, you know, it's not smooth enough. So what we do is we do smoothing. We click Gaussian, and you can set this value to be probably around 5 to 7. So I'll put at 6, and you click apply. So that's, you know, it's smoothened and it looks pretty okay now. We can work with this, I think. If you zoom in, zoom out, you can probably can see the geometry better. So just a recap, we did a separate segmentation on the vein and the artery, and now we have a full STL file. And we need to, this is all in 3D slicer, so we need to do a export to have a STL file. So what we do is we click segmentation and we click model, and then under export to file we pick where we want the file to be. So in this case I will just put it in this file, and I'll choose, and you tick this 2 button and you export it. So you can see that this is the file that's exported. Yeah, so this is the STL file. I'm pretty happy about it. Right, so once we finish with 3D slicer, we will have a STL that looks like that. And the next step is to extend the boundary at these 3 different locations. And the reason why you want to extend that is so that the flow can develop better when we run the CFD simulation. So we use this software called the VMTK. You should have them in your lab computer. And you'll be provided with the code that looks something like that. So note that this bit here will need to be the location of where your STL is stored. And I'll just explain some of the different things that are pretty important, but you could just use the default code. So the VMTK flow extension, we'll have it at 10, the ratio to be 10. That's just so that the ratio of the extension to be 10. And the export writer, so the surface writer, VMTK surface writer, is where your file will be write as. So I'll name it as modeldone.stl. So once you copy the code, and you can choose to run current line, run selection, or run all. I choose to run all now. And the next one that you will see is this screen here. So you can use different smoothing method before VMTK to smooth the geometry. There's software like MeshLab or different things, but this is this one was just right off 3D slicer. So if you don't think that it's smooth enough, you can use MeshLab. So now it says that position the mouse to press space to add source. The source will be this bit here. We call it the distal artery. And so I press the space, and then you will see a red button, and I click Q. So now it asks me to press and choose the target. So the target will be these 2 bits here. And that's what we call the proximal vein, which is this vein, and the proximal artery. So same thing, I quit rendering because I'm done with the whole rendering. Now it's computing the center line. So if you look at the image, it says not responding, but if you click the task manager, it's actually working at the background. And if you see Python is running, don't be afraid, just give it a few minutes before it computes the center line. So once you the center lines finish computing, you will see that there's different things that is shown here under the command. So that's basically executing the code that we provide. So now it says please input boundary IDs, and if you look at the image here, there's 3 different IDs that we have. So what we do is we input the ID, so it's 0 space 1 space 2. Click enter. So if you see that it's not responding, don't be afraid. What you can do is you check your documents and see if anything is accomplished. So if here I looked at, so there's this model done. Essentially what it's basically done with all the extension, and you look at the image, there's this extension that is being placed from the geometry that we have. So that's all from 3D Slicer and VMTK. Hopefully that was helpful for you.